Hello everybody, welcome back to Leetcode Simplified. I'm Alan, and in today's episode, we're tackling Leetcode 190, reverse bits. Reverse bits of a given 32-bit size integer. Well, the first thing might come to mind is the naive approach. Convert the integer into a binary string, then revert the string and convert it back into an integer. This works perfectly, but it's inefficient and involves string operations. Instead, we can do this directly with bit operations. For example, given integer 13, its 4-bit binary is 1101. We demo with a 4-bit integer to keep it simple, but the exact same logic applies to 32 bits. Here's how we're going to reverse number 13 bits with direct bit manipulation in Python. First, create variable result to hold the reverse number. Initialize it to 0. Since this is a 4-bit, we're going to perform the following steps 4 times. Shift result left by 1 bit to make space. N and 1 reviews the last bit of N. Then we OR that bit with result to append it to the result. N and 1. Anything N with 0 becomes 0. Anything N with 1 stay the same. So 1 here and with 1 will stay the same. Then we OR it with the result to append that bit to the result and update the result. Anything OR with 0 stay the same. So this won't change. Similarly, anything's here OR with 0 stay the same. So we update result. Now we shift and write by 1 bit, making the next bit ready for the next iteration. Second iteration, shift result left by 1 bit to make space. N and 1 to get the last bit of N to here and append it to result by OR it with result. Shift and write by 1 bit, making the next bit ready for the next iteration. Iteration 3, shift result left by 1 bit to make space. N and 1 to get the last bit of N, then OR it with the result to append that bit to the result. Shift and write by 1 bit, making the next bit ready for the next and last iteration. The fourth and last iteration, shift result left by 1 bit to make space. N and 1 to get the last bit of N, then OR it with result to append it to the result. So reverse the bits of 13. We got 1011 or integer 11. For 32-bit integer, the exact same steps apply. Just repeat 32 times. At the end, result contains the reverse integer. Alright, it's time to smash the submit button. Moment of truth. Boom, accepted. This algorithm runs in big O of 31 time complexity with E constant, so we treat it as big O of 1. And it uses big O of 1 space complexity since we use only 2 variables, result and N. And that's it for today. We saw Leetcode 190 reverse bits using a clean and efficient bit manipulation approach. If you found this explanation helpful, don't forget to subscribe and check out the playlist for more Leetcode problems explained simply and clearly. I'm Alan and this was Leetcode Simplified. Thanks for watching, and I'll see you